If there are no further questions, then we'll thank the speaker again. And the next speaker is Gergely Dalya, talking about the UpGLADE catalog, a significant improvement on the GLADE catalog.
All right. Yeah. So, welcome everybody. I'm Gergely Dalya from here from the LDZT. And in this talk, I would like to talk about the new version of the GLADE catalog. All right. So, as a quick motivation, as you know, the sky areas of the GW events that we have with two detectors are very, very large. So there is no chance of just seeing the EM counterpart for those. If we have three detector observations, then it's a bit better. It's a couple tens of square degrees. But for small field of view telescopes, it can still be quite a big challenge to go through all of that sky area. So a better approach is to only focus on the galaxies inside that area and just go through the galaxies one by one, observe them, and compare it with previous images. So in fortunate cases, if the event is close by, then we know all of these galaxies and maybe we can rank them based on some properties like the stellar mass or star formation rate, or just picking and choosing our favorite astrophysical model to rank them in order to maximize the chance of finding the counterpart and observing it as early as possible so we can get all the valuable information from that. So then, in the end, we get something like this, the picture that we all know and love. But apart from just achieving the observation itself, of course, it's a treasure trove of all kinds of astrophysical and cosmological information. So what is most important for me personally is the cosmological information. So Nicola already showed this picture, I believe, the first standard siren Hubble constant measurement that we got from GW 170817. But as you know, there has only been one such observation so far. So as Nicola told in his presentation, what we can do in the absence of these observed counterparts, we can use the so-called dark siren method. So just as a quick recap, the point of this method is that we treat all galaxies in the localization volume as possible hosts of the BNS merger, and then use the redshift information from the galaxy catalog to compare with the luminosity distance that we got directly from the gravitational wave itself. So, of course, for this, it's also crucial that we have a very complete galaxy catalog up to very high distances. Another advantage of this method is that we are not just relying on BNS mergers, but we can also use BBH mergers, for which we wouldn't expect a counterpart in other cases. So these were the main motivations when we back in 2018 created the first version of the GLADE catalogs to have the EM follow-up, to provide some input data for the cosmological inference with gravitational waves. But also later we realized that a lot of teams started to using the catalog for identifications of EM transients post galaxies. So for GRBs, FRBs, and a lot of other transient phenomena. So yeah, this one was a quite small catalog, just a couple millions of galaxies. So then we continued the development of the catalogs as new observations became available, as we get to know new galaxies and new properties of those. So the next version was GLADE Plus, which added 20 million new galaxies, and for that, we also tried different photo-Z pipelines, so to try to improve the photo-Z estimates, because as I will show later on, it's still a crucial piece for the cosmological inference, and the accuracy of the photometric redshift really hinders our accuracy in the cosmological inference. Another key thing is the peculiar velocities of the galaxies, because we expect most of the cosmological information to come from the very close by, very well localized GW events, because yeah, for those we have fewer possible host galaxies. So even if we don't observe the counterpart itself, we can get a tighter constraint on the Hubble constant. However, for these events, the very close by, very well localized events, it's crucial to take into account the peculiar velocities, as we saw with the very first standard siren observation as well. So we started adding peculiar velocity estimates to the catalogs as well. And another new point was to add some more properties, some more inferred properties of these galaxies, so that people can rank them based on these properties. Initially, what we did was just to use the magnitudes themselves, but for this catalog, we already added stellar masses and then binary neutron star merger rates based on some very simple models. And now I'd like to talk about the newest version of the catalogs, which is called UpGLADE. It's a huge improvement compared to the previous one because it contains more than 1 billion galaxies. So it's 2 orders of magnitude more than in GLADE Plus itself. We compiled it using a bunch of different new surveys. For example, the legacy survey. You can see clearly the sky patches coming from the legacy survey. We have pan-stars, so you can see the minus 30 degrees declination boundaries here that come from pan-stars. And yeah, because of that, of course, at the southern hemisphere, we don't have as large of a completeness as in north from minus 30 degrees in declination. So we tried to complement that with the SkyMapper survey, which was specifically done for the southern hemisphere. But still, in the figure, you can see that the catalog is not as deep in these parts of the sky. We also added as much spectroscopic redshifts as we could, because, as I said, the redshift accuracy is currently what is hindering the cosmological analysis the most. And we included more photometric bands, so that based on those, people can select the galaxies that are of interest for them. Yeah, as I mentioned, the peculiar velocities are very crucial for these close by, well localized events. So we improved the peculiar velocity estimations as well. We started to use a new pipeline, and also based on the more photometric bands that we have available, we could do a better estimation of stellar masses and star formation rates. So now it's easier to rank the galaxies based on those and not just the magnitudes. Okay, so what can we say about this catalog? First of all, what's really crucial for us is the completeness of the catalog. So how far away the catalog reaches, basically. It's quite hard to quantify the completeness for such a catalog because it's a composite of a bunch of different data sets, and because of that, towards different sky directions, you have widely different limiting magnitudes and hence widely different completeness values. So how can we approach this? We can use the Schechter function, which just gives you the number of galaxies per luminosity or magnitude intervals. So here you can see how the Schechter function fits the galaxy distribution in the catalog in the G band, just for some area of the sky for which we are pretty complete. What you would expect is that as we go farther away, then the faint end, here is the faint end of the Schechter function, you're going to start losing some of the galaxies here. So you would have some figure like this. So based on integrating the Schechter function and integrating the total light from the galaxies in your catalog, you can calculate the completeness of the galaxy catalog. In order to get this figure, we did 2 more interesting things. First of all, to address the anisotropy and to address that, of course, brighter galaxies you would see from farther away. We used the 1/Vmax weighting of the galaxies. And to make this plot, we also took into account the redshift uncertainties, because, as I mentioned, We have mostly photoses, and those can be quite uncertain. So what you can see in this figure is the probability of the host galaxy being in the catalog as a function of the event's redshift. Okay, and we have a couple of different lines because, as I mentioned, to different sky directions, the completeness will be wildly different. So as I showed in the southern hemisphere, for example, the completeness will be way lower. So how can we read this plot? We can see that for 95% of the sky, we have a magnitude threshold that is larger than 24.4. For 80%, larger than this value, etc. And then these curves correspond to those different magnitude thresholds. So yeah, what's the takeaway message from this plot is that we are complete to, let's say, z equals 0.5, almost for the whole sky. And if we want to compare this with the previous catalog, that was a redshift of 0.1 in the B band, and even worse in the K band or in other bands. So it's a big improvement from 0.1 to 0.5. Another new thing that we provide now is in the catalog compared to previous versions is K corrections. So yeah, previously, if people wanted to use it for cosmology or for anything else, of course, the user had to compute the K corrections. But yeah, for this many galaxies, it wouldn't be a very straightforward computation. So we decided to provide this natively in the catalog itself. So yeah, here you can just see some different Schechter functions in a very incomplete part of the sky at different redshift bins. So if we don't do the K correction, then you can see that the bright end of these Schechter functions wouldn't fit very well. So of course it would introduce a bias in the cosmological inference. But if you do the K correction, then you can see that the bright ends match up very well with each other. Okay, and yeah, as I mentioned, for most of the galaxies, of course, we just have photoses, and those have quite large uncertainties. So we wanted to include as many spectroscopic redshifts as possible, but still, if you take a look at this figure here on the left-hand side, you can see that still for a bunch of galaxies, the photosy errors are around 50%, or for some even higher than 50%. So of course, that's not very useful for either counterpart searches or for age-naught estimations. So we try to use a couple of different photosy pipelines while putting together the catalog, but mostly we are restricted of the different pipelines that have been used for the specific surveys. So for example, for the Pan-STARRS survey, they use the machine learning pipeline for the photoses, and most of these really, really uncertain galaxies come from that pipeline. Another thing that we are doing right now is that the DESI first data release happened quite recently, a couple of weeks ago, which provides spectroscopic redshifts for 13 million galaxies. So we are folding in that data set to the catalog right now. But yeah, this is the footprint of the data release. So of course, it doesn't cover the whole sky, but at least for these areas of the sky, we will have much better data from the DESI DR1. Okay, so how can we access the catalog? Right now, it is a PostgreSQL database on the LIGO Virgo Kagra cluster. So for those of you who are members of the collaboration, you can already access it in the cluster. For those of you who are not, we are working hard to make it public as soon as possible. There are plans to integrate it to GraceDB itself. So whenever there would be a new alert in GraceDB, it would already contain a list of possible host galaxies from the catalog. So that's what we are working on now to try to implement. Yeah, we are not sure when will we be able to finish it. But with this new database structure, it's also very fast to query the Galaxy catalog, and we can very simply add other databases to the catalog as well. So right now, it's already on the cluster itself. It's already cross-meshed with UpGLADE Plus and with Pan-STARRS. So if you want to do some different cuts in some parameters like the probability of it being a star or being a galaxy. If you want to play around with that, it's super easy to do. And yeah, with this new database structure, it's just much faster to handle the 1 billion objects. Yeah. Finally, in the end, I would like to mention some other projects that we have been working on. So there is UpGLADE, which is an interactive web tool to evaluate the completeness of our catalogs. Right now it's for UpGLADE Plus, but in a couple of months, we plan to extend it for UpGLADE as well. So it's a tool to help the EM follow-up of the GW events, which interactively shows you all the UpGLADE Plus galaxies automatically in for any super event that arrives in GraceDB. And it also calculates the completeness of the galaxy catalog in that volume of the sky. Okay, so that you can make a more informed decision whether I would like to use my precious telescope time to try to follow up these galaxies, or I see that, oh, okay, the completeness is only 1% in this area of the sky, so I need a different approach. Maybe I will just do another super event. And yeah, finally, what we are aiming towards is Gladiator, which would facilitate observations for both EM follow-up and for dark siren cosmology. So it aims to be a platform where we collect new galaxy observations and integrate those to our catalogs. So imagine that you have a gravitational wave event, which is quite close by, but you don't observe any counterpart of it. These events, they are very well localized, so they would be really super useful for cosmology. And if only we had good galaxy catalog support. But if it's on an area on the sky where we don't have very much completeness in the galaxy catalog, then it's not really useful for the cosmological analysis. What we can do in that case is to facilitate some observations, some follow-up observations, not for any EM transient, but just to find more galaxies in that sky area. Okay, and the great part of this is that it can be done anytime after the GW events. So it's not, we don't need a rapid response from any telescope team. Whenever there is some time, some free telescope time, any team could do some follow-up observations and thereby contribute very significantly to the Hubble constant estimation. So yeah, and if there are multiple teams who are already contributing to these observations, then we can include all of these newly discovered galaxies straight to the galaxy catalogs through this new tool. And then, of course, for the future gravitational wave events, we will already know these galaxies. Yeah, we don't necessarily need to discover new galaxies, so that's one thing that we could do. Another thing would be to do follow-up observations, let's say spectroscopic observations, or just observations with a better telescope to the galaxies that we already know in that sky area. So it would solve the issue of only having photometric redshifts for those galaxies if we can do some spectroscopic observations just for the most well-localized GW events. So that's all I wanted to say. Thank you very much.
Thank you very much for the talk. Questions from the audience?
Thanks a lot. It looks really great. I didn't quite understand the data access ideas that you had. So you have this database that is accessible currently only to LIGO Virgo members, and then you try to integrate it to GraceDB, but will you make the whole catalog accessible to people from the outside, or only these cross-matched GW events with the catalog? Or
yeah, so the plan is that in the end we want to make it accessible, the whole catalog itself. So yeah, there are still things to figure out how to do that through the LIGO cluster. Okay, so yeah, just the technical things basically, because yeah, most of the data there is confidential for people outside of the collaboration. So Yeah, if we can't find a solution for that, then of course the solution could be to just host it somewhere else and then make it public that way. But right now, because the catalog is developed in the cosmology group of the collaboration, it was a first logical place to start storing the catalog there.
And that LIGO server would also be available after 04, or would it be switched off and come online only for 05, or is that
No,
a continuous service that would be available? Or?
Yeah, it would be available throughout the whole time. So.
Thanks.
Thanks. So I wanted to ask you about your photometric redshifts, because as you said, those are kind of critical to using. So two connected questions. The first one is, you've got 1.3 million spectroscopic redshifts. So do you have a plot for those of spectroscopic redshift against photometric redshift, just to see, it gives you a good indication of how reliable, at least in that range, the photo Zs are? And then more generally was how they're created, because it sounded like it might be a bit heterogeneous, the way they're created. I know a concern I had, I think I probably corresponded with you about with the very earliest version of GLADE, was that you have machine learning to get some of the colors and then to get the photo Z, which is a bit self-referential. So can you just give us any indication of how that's working now and what the reliability of the photo Zs is?
Yeah, thank you. Yeah, I don't yet have a plot of the photo Zs versus spectral Z, so it's something that we are working on right now. But in a week or two, I think we should have something. About the photo Zs, yeah, for the different subcatalogs, let's say, of UpGLADE, very different methods have been used. So I already mentioned Pan-STARRS. There they inferred the photo Z at the same time as inferring the type of the object. Okay, so whether it's a star or a galaxy. So those are kind of linked there. For the legacy survey, we have used two different photo Z methods. So one of them was from Ken Duncan, and the other is from Zhou et al. For that, we corresponded with the authors, and they said that, yeah, my photo Z method is better for these kind of galaxies, mine is better for these kind of galaxies. So we kind of, just use that information to use one of the photo Z methods for a subclass of galaxies.
Okay. So an overlapping question with that is, where you've got, so a lot of these galaxies will be in multiple different surveys. So do you just present, in that case, each of the photo Zs so we can choose, or do you have a recipe for deciding, let's say it's in Pan-STARRS and the legacy survey, which one do you go with, or how do we get that?
Yeah, in those cases, we just went with the legacy survey photo Z methods because those were much better.
Okay. Thank you.
That's, yeah, much lower errors and also much fewer outliers.
Hi, thanks for this talk. As you know, I'm a big fan of the GLADE catalog. I was just wondering, because, so the UpGLADE catalog is obviously not available to the public, and I understand it's really difficult to do that. Can you not just dump it on Vizia?
Yeah, I think we could do that.
That would be brilliant if you could, because I mean, make it public and people can then access it. I mean, it's great if you've got a server that can do things that are more interesting and stuff, but if it could just be on Vizia, then I know it'd be used by many people.
So what would be the technical way to do that? Because, yeah, the catalog is like more than 1 terabyte now. I'm not sure if there is any issues with that.
I don't know, more technical people than me. I mean, the Gaia catalog's on there, so they managed it. And there's a web page that already tells you exactly what you need to do. I've only done smaller catalogs, which is why I don't know about the really, really big catalogs.
Proprietary. How does this help if they can't release it because there's some proprietary information in it? How does it help them to?
No, it's we only use public data for this.
So it's really just a technical problem to release the data. I mean, terabyte is not so much.
Okay, that's a good idea. Yeah, thank you.
Okay. In which case, we need to move on to the last talk. So thank you again to the speaker.